Okay, today we're going to be moving on to chapter 9, and this is where we combine geometric growth and decay. So remember, growth is when you're adding more. So geometric growth too is so like if we're timesing something by 1.05, we're increasing it by 5%. And the decay is we're going to reduce it, so we might minus something. So an example of this situation is when we have loans from the bank, because obviously the loans we have to pay interest, and that's the growth, but we want to pay it off, so the payments we make end up being the decay because we're trying to reduce the loan. So we're just going to have a look at basic recurrence relations with this combination. So write down the first 5 terms of the sequence generated by the following recurrence relation. It's a recurrence relation because it has a VO and an n+1. You can see this timesing by 2 is the growth, and then minusing 10 is the decay. So we can pop these in exactly what we've been doing. So we put the first term in, T0 or whatever, click enter, and then if you press times 2, you should see the word answer come up, and then you do times 2 minus 10. So we should get 90, which we see here, and you keep pressing enter and so on. So there'd be 1, 2, 3, 4. There's the first 5 terms. Now, the following recurrence relation, so here's a recurrence relation, can be used to model the amount of water in a swimming pool after n days. So they're just saying this WN indicates how much water is in the pool each day. Each day, 1.4% of the pool, the water in the pool, is lost. So this is actually here, we've just listed a geometric decay, because if you're losing it, a geometric decay. So this is like a reducing balance. So if you remember, if you look at our remember we did 1 minus the rate over 100. So in this example, it's 1 minus 1.4 over 100. So you can see our rate, or what we're timesing it by, should be 0.986. So that's where they've got that value. And then at the end of each day, because they're losing water, they add. So this is actually a... this one's an arithmetic growth. So we've sort of mixed it up here. Okay, so then you add it. So it says how many litres, correct to the nearest litre, will be in the swimming pool after 5 days. That's like getting, you put in the first term, VO, so that's not the first day. Then you do your thing where you times by 0.986 and add 1,000. So there's day 1. Day 2, I should be calling it W because that's what they called it, 3, and day 4, and day 5. So here's day 5. Now they said the nearest litre, so I've rounded that up. Okay, with these ones where it says how many days will it take, because the formula for the next term, it's a combination, so we can't really use our nth term formula here, so we're probably just going to have to keep clicking in. I doubt you'd get this further ahead. Apparently it took 21 days. You can just keep clicking enter and see how you go. I don't think it's worth learning this part. Alright, so you should be able to do exercise 9A, question 3. And then I'll keep going because it's the next part. So here's an exam question. Consider the recurrence relation. Yes, it's a recurrence, VO. Now this is growth because it's bigger than 1. And this is also growth as well. So the recurrence relation could be used to model, well, it's not a reducing balance because that is a decay. So I'm going to say no to that one. A reducing balance loan. It could be a loan in the fact that it's growing, but then the payments would be minus 500. So I'm going to say no to that. Oh, you haven't learnt what a perpetuity is yet. So I might leave this question. We'll come back to this one. Okay, so now here we're just looking at setting up proper recurrence relations with this reducing balance loans. Nearly all the loans we get from the bank are going to be, generally reducing balance because we want to pay them off. So a reducing balance loan is a loan with compound interest, but it is reduced in value by making regular payments. So each payment partly pays the interest that has been added and partly pays a bit of the loan off. Okay, so we saw this before. So because if it's a loan, you're going to get the growth because the bank want to make money off lending you money. And then this is the decay and this is your payments that you're trying to do. Okay, so we can think you should still get a curved graph with this scenario generally. So here we know, and so we still work out the same thing. So the growth part, the R value, is found the same as we did before. So be careful, that would be divided by n there. And the decay will be the payments made. All right, so just remember the payments and the interest rate compounding period has to match up. So if you're making monthly payments, we're making monthly payments, we'll be making compounding it monthly as well. Okay, so they have to match up. Compounding monthly, yeah, interest. Okay, so if we have a look, Jack borrows $1,000, so that's my VO at an interest rate of 15 per annum. So this is your R, and when they say compounding monthly, that means our N equals 12. So you can see here, I divided it down there. So when you're working out the rate, you can do it all in one go. I could have gone 1 plus 115 divided by 12 over 100 and press enter, and I would have got the 1.0125. Okay, she will repay the loan by making 4 monthly payments. So here's her monthly payment. So that's like your D value there. Construct a recurrence relation. So we found the R. So we've gone to the formula and we know we've got to do the R value. So there it is, times the one before. And then remember, this is the payments. So if you're asked to construct a recurrence relation, we need to state the VO and have the formula. Then it says use your calculator to determine the loan after 4 payments. So I should have had the first one in here. You'll see 1,000, press enter, and you get 1,000 over there. Then we do this one where we did answer times the rate and then minus that. So here's after 1, 2, 3, after 4 payments, she still owes 4 cents. So the loan is fully paid after 4 payments. Is the loan fully paid off? If not, how much will the last payment have to be to ensure your 4 payments? So she didn't quite pay it off. She still owed 4 cents. So what they do is they just add that to the last payment and to zero it off to get it done.